Hello everyone. Today I'm going to present skin safety assessment according to OECD guideline. I'll first give a brief introduction of the new guideline OECD TG 497. Then I will describe its individual guidelines and the defined approaches mentioned within TG 497. Then I'll present some examples and discuss its hazard assessment following the guideline, and also compare it with different approaches which is present in SaferSkin app. There are some examples which has same outcome using different approaches, and then later on I will present some examples which has different outcome using different approaches. In June this year, OECD published this new guideline, and it's quite remarkable because for the first time, without the need of animal testing, hazard assessment, as well as the hazard classification could be assessed, and uh, OECD has also published individual guidelines like TG442C, TG442D, and TG442DE. However, it should be noted that these individual guidelines cannot be used on its own. In the new guideline, together they could be used. I would also like to point out, for the first time, two in silico approaches has also been introduced in TG497. The first guideline describes the adverse outcome pathway, the key event 1, which is covalent interaction with the skin protein. The second assay, which is the keratinosense assay, that describes the keratinocytes activation within the adverse outcome pathway. And the third assay, which is human cell line activation assay, that is HCLAT, that represents the dendritic cell activation. And there is up till now no approved assay for the fourth key event, which is T cell activation and proliferation. There are two new advanced assays which are also under consideration, which is Sensis and guard skin assay. However, up till now, these have not been introduced, but they would be introduced, they would be approved within TG497. The different assay as it is already published. So its borderline range as well as the applicability domain has also been passed to the new guideline TG497. For example, this is the flow chart of DPRA assay, that is key event 1, and there is clear indication of borderline range within key event 1. For example, the mean peptide depletion when it is between 4.95 and 8.32%, then it is considered within the borderline range. And same, it is a very easy flowchart diagram and decision based tree, and everything is explained. If there are two positive, then the final outcome is positive. If there are two negative, then the final outcome is negative. And if the two results are borderline, then the final outcome of hazard assessment is borderline for the given compound. Similar is the flowchart for second key event, that is the keratinosense assay. Here also there is clear description when the induction of keratinocytes is more than 1.35 fold, and it is statistically significant, then you need to consider for the borderline range, and there is clear demarcation when it is borderline and when it is negative and when it is inconclusive and when the assay need to be repeated. Same is with the third key event, that is the HCLAT assay. HCLAT assay is the dendritic cell activation assay, where CD54 and CD86 induction is assessed, and here also clear indication when the when the result is positive or negative or borderline has been mentioned within the guideline. There are mainly two defined approaches explained in the new guideline, and the first one is 2 out of 3 defined approach, and it's basically the decision tree. When out of these 3 essay, if 2 of the essay has same outcome, then the assessment is clear. For example, if 2 essay has conclusive result, then it is clear whether it's sensitizer or non-sensitizer. However, if there is non-concordant result, then the third essay need to be done, and it needs to be checked whether it has the same result or not, or a different result. So here I would like to point out that the applicability domain needs to be checked for the hazard assessment. With this defined approach, only hazard assessment could be done, and potency classification could not be done. The second defined approach is integrated testing strategy, and within the guideline there are actually 2 different versions, ITS V1 and ITS V2. As I said that it is the first time 2 in silico software has been used for hazard assessment. So these 2 versions actually is dependent on whether which software has been used. ITS V1 direct nexus is being used for hazard assessment, and in ITS V2 OECD toolbox is being used. Direct Nexus is actually a paid software, and OECD Toolbox is freely available software. In my examples, when I'll discuss the outcome and hazard assessment, I will mainly discuss with regards to the OECD Toolbox outcome, and that is ITS version 2. In ITS also, it is a decision-based tree. There is we need to test whether all the 3 assays are available or not, and for ITS we need only 2 assays. If 2 assays are available and if the applicability domain is available, then we need to ask whether in silico prediction is present and if the outcome is within domain. There is also one more possibility in this decision tree, that if only 1 assay is available and applicable and there is result of in silico assay, whether from direct nexus or from OECD toolbox, then also the hazard assessment and potency classification could be done. It is also very interesting that within ITS there is a very clear marking or score-based system for each essay system. For example, this is the score system for HCLAT. If MIT is within 150 microgram per ml and 5000 microgram per ml, then the score contribution is 1. And if the MIT is between 10 and 150 microgram per ml, then score contribution is 2. Same is in the case of DPRA. If the mean peptide depletion is less than 6.38%, then score contribution is 0. And similarly, there is a score contribution from the in silico domain, whether it's in version 1 by direct or in version 2. If the outcome is negative, score contribution is 0. And if the result is positive, then the score contribution is 1. So the potency classification of any chemical could be assessed by calculating total battery score. If the total battery score is between 0 and 1, then it is the chemical is not classified. If the total battery score is between 2 and 5, then the potency classification is under UNGHS 1B. And if the total battery score is 6 or 7, then UNGHS 1A. UNGHS 1A is mainly a strong sensitizer. I would also like to point a very interesting thing within this new guideline is that even if the result is inconclusive and then also it could be reported as weight of evidence. For example, here there are uh, uh, 2 points where there could be inconclusive result and it could be submitted as weight of evidence. So now I will briefly explain different examples. First 3 examples are the easy examples where all the different approaches give same outcome, and then I will discuss different examples where different approaches have different results. So first example is Farnesal, and here the 3 different assay, for example, DPRA is positive, the keratinosense is also positive, and HCLAT is also positive. So all the 3 assays is positive. So within following the guideline, the first defined approach, that is 2 out of 3 defined approach, it is easily classified as sensitizer. Same using ITSV version 2 defined approach. 2 assays are available and in silico prediction is also available. So the outcome from OECD toolbox was positive, and so the score contribution was 1. Similarly, as I explained that within this guideline, there is defined score contribution in each assay. So for this example, for Farnesal, the score contribution of DPRA assay was 1, and the score contribution from HCLAT was 2, and so the total battery score was 4, which makes Farnesal in UNGHS 1B, that is a weak or moderate sensitizer. There is no distinct classification within this guideline as weak or moderate. Both comes within UNGHS 1B. The different approach which was used is within the SaferSkin app, and within the SaferSkin app there is a Bayesian network which can classify different chemical into 4 different classes, either not classified, a weak sensitizer, moderate sensitizer, and a strong sensitizer. And Bayesian network also gives the potency and like potency quantification with PEC3 value. Within the SaferSkin app, there is this different approach, that is multiple regression, and this also classifies any chemical as non-sensitizer, weak sensitizer, moderate sensitizer, and strong sensitizer, and also gives the PEC3 value. Within the guideline, there is only the classification as sensitizer or non-sensitizer, and with ITS version 1 or 2, it can be classified UNGHS 1B or 1A. However, there is no description of PEC3 value or any other quantification method. within Bayesian network, times is a predictor, and it's the main contributor for within the Bayesian network. So for Farnesal, times also classified Farnesal as moderate and a strong sensitizer. So this example is a very good example where all the approaches classifies Farnesal as sensitizer. Like Farnesal, Safranal is also similar, where all different approaches classify Safranal as sensitizer. This is one example where I have chosen Safranal, which is a strong sensitizer. So DPRA was positive, HCLAT and keratosense, all three assays are positive. So following TG497, 2 out of 3 defined approach, it is easily classified as sensitizer. And following ITS version 2, the score contribution was 3 from DPRA, and the score contribution from HCLAT was 2. And in OECD toolbox, there was a structural alert. So the score contribution was 1. So for Safranal, the total battery score within ITS V2 was 6. That classified Safranal as a strong sensitizer. So same, if we follow the decision tree using ITS V2, both assays are applicable. In silico prediction is available and it is in domain, and total score contribution classifies Safranal as UNGHS1A. The different approaches within SaferSkin app, Bayesian network also classifies Safranal as a sensitizer, and with a PEC3 value of minus 0.48. Similar was the case with multiple regression approach. Safranal was a moderate sensitizer with a PEC3 value of 0.44. And times also predicted Safranal as moderate and or strong sensitizer. Next example is also a easy example where all the different approaches predicted butoxyethyl acetate as non-sensitizer. All three assays has negative result. So following TG497, 2 out of 3 defined approach, butoxyethyl acetate is a non-sensitizer. And following ITS version 2 defined approach, DPRA score contribution is 0. Same is with HCLAT and OECD toolbox. So in ITS V2 decision tree, it was easily and conclusively classified as non-sensitizer. Within the SaferSkin app, Bayesian network and multiple regression both predicted butoxyethyl acetate as non-sensitizer. This is the next example, which is 3-dimethylamino propylamine. And here, all different approaches predicted this compound as sensitizer except for multiple regression. Here the DPRA was within the borderline following TG497 guideline. It was positive for HCLAT and it was positive for keratosense. So following 2 out of 3 defined approach, it was easy. It was predicted as sensitizer. The score contribution for DPRA was 0. For HCLAT was 2, and for OECD toolbox was 1. So the total score contribution for 3-dimethylamino propylamine was 3, and using the ITS V2, it was classified under UNGHS1B. it was similarly predicted as moderate sensitizer by Bayesian network with a PEC3 value of -0.75. Times also predicted 3-dimethylamino propylamine as moderate sensitizer. So when we compare both the defined approaches within the guideline and Bayesian network predicted 3-dimethylamino propylamine as sensitizer, except the multiple regression. Next example is furyl. This is also an interesting example where the DPRA is positive and the result is quite high. So the score contribution within ITS V2 is quite high and 3. Keratosense is positive and HCLAT is borderline. So 2 out of 3 defined approach easily predicted furyl as sensitizer. And following ITS V2, 2 assays were available and applicable. And the in silico domain, in silico prediction was also there and within domain, and total score contribution was 5 that classified furyl as UNGHS1B. So this was an interesting example. While the in silico domain, in silico software which is within this guideline predicted furyl as a sensitizer, however times predicted furyl as non-sensitizer. And multiple regression, however, on the other hand, predicted furyl as sensitizer with a PEC3 value of -0.68. So here, both defined approaches within the guideline and multiple regression predicted furyl as sensitizer. However, Bayesian network predicted it as non-sensitizer. Next example is benzyl alcohol, and it is also quite interesting because within the guideline, 2 defined approaches predict differently for benzyl alcohol. DPRA was negative. The result for HCLAT was positive, and the result for keratosense was negative. So within the 2 out of 3 following the 2 out of 3 defined approach, benzyl alcohol was classified as non-sensitizer. However, the total score contribution using ITS V2 was 2, which makes benzyl alcohol under UNGHS1B, that is weak sensitizer. Bayesian network and multiple regression also predicted benzyl alcohol as non-sensitizer. Only the in silico prediction within the guideline predicted benzyl alcohol as sensitizer. And the OECD toolbox was actually a structural alert based on retest cross that contributed mainly for the hazard hazard classification for benzyl alcohol. Like benzyl alcohol, squaric acid also has same outcome. 2 out of 3 defined approach predicted squaric acid as non-sensitizer. However, ITS V2 predicted squaric acid as a sensitizer. So when we see individual result, DPRA was positive, HCLAT was negative, and keratosense was negative. So 2 out of 3 defined approach predicted squaric acid as non-sensitizer. And when we calculate the square total score contribution, so from DPRA it was 2, and from OECD toolbox it was 1, making the total score contribution of squaric acid 3, which which comes under UNGHS 1B. Here, Bayesian network predicted squaric acid as moderate sensitizer. Times also predicted squaric acid as sensitizer. And from Bayesian network, PEC3 value was minus 2.49. However, multiple regression and 2 out of 3 defined approach predicted squaric acid as non-sensitizer. This is the last example which I wanted to show, where inconclusive result can also be obtained and it can also be submitted as weight of evidence. This is the example with compound name 2-ethyl 2E4Z24 decadienoate, and this was interesting because all the data is from REACH dossier, and the data is not conclusive, or the result is not conclusive for the DPRA because it was not within the domain, which is explained in the individual guideline. For HCLAT also, the result was not within the domain. The log KOW was greater than 3.5, and only result was conclusive for keratinosense, which was negative. So here we cannot use 2 out of 3 defined approach because we have only one result, and using ITS V2, 0 was the score contribution from keratinosense, and there was a structural alert in OECD toolbox. So the total score was 1, and for ITS V2, this decision tree is followed like this. Only one assay is available and in silico prediction is there, and it is within domain, and the total result, total outcome is inconclusive. So this is what is also interesting within this new guideline, that inconclusive result is possible and it could be submitted, and maybe the new, when 2 new assays are added, it will give much more weightage, and hazard assessment and potency classification would become much easier. So I will now open for discussion, and just to conclude that there are some examples where using different approaches we get same outcome, and there are certain interesting examples where different approaches predict compound differently, and then we need to decide uh, whether how to proceed about it. Even within the guidelines, there were examples where 2 out of 3 defined approach predicted compound as non-sensitizer, and when we take account from the in silico prediction and using the ITS, then compound is predicted as sensitizer. So these are all interesting examples, and now I will open for discussion, and we should uh, discuss how to go about all these different examples, and for different chemicals, what should be done. Thank you for your attention.